Hi everybody, here's number 1 on our new problem set. And we have n equal to 81. They took a sample of size 81. The x bar is 57.8. The s is 6.02. Now here's a couple of quick notes. When n, whoops, can't even write tonight. When n is greater than 30, s is, for our purposes, equal to sigma. So if you want sigma in them instead of s, you can go ahead and use them. Okay, so our formula for this particular setup is x bar plus or minus z with alpha over 2 times sigma over the square root of n. So the only thing we have left to get is the z value. Okay, we know this is a 95% confidence interval, so we take 1 minus alpha, and that's equal to 0.95, referring to the 95%. Then we take 1 minus alpha over 2, which is 0.95 over 2, which is 0.4750. Okay, so what we're going to do is look in the middle of our normal table for the closest value to 4750, and we find that at 1.9 and 0.06, that actually has an exact value, and it's 1.96. Okay, so let's go ahead and put all this stuff together. And we have 57.8 plus or minus 1.96 times 6.02 over the square root of 81. Okay, so we're going to have 57.8 plus or minus 1.96 times 0.6689. And that's going to be 57.8 plus or minus 1.31. And when you do all your hand waving, you end up with 56.49. Less than mean mu, less than 59.11. Okay, now let's talk about the interpretation. And the basic structure is the same on any kind of confidence interval. What we do here is think about, well, we don't know what mu is, okay? So what we are trying to do is estimate an interval for mu. All right, so now when we get that, we say that we are 95% sure that the mean mu is in that interval. So about 95% it's in there, 95% of the time it's in, about 5% it's out, but that still gives us a lot more to work with than negative infinity to positive infinity. Okay, thanks.